Welcome to The Explainer. Today, we are taking on the butterfly effect. But here's the thing, it's not just about the science. We're going to uncover a hidden paradox that might just break our entire idea of cause and effect.
Right, you know the story. It's practically a modern myth, isn't it? Some tiny butterfly flaps its wings down in Brazil, and that little flutter, weeks later, somehow kicks off a massive tornado in Texas.
So where does this powerful idea come from? Well, it goes back to a 1972 talk by the meteorologist Edward Lorenz, who was basically the father of chaos theory. And right from the very beginning, Lorenz pointed out something really important that we all tend to forget. That exact same flap could just as easily have prevented a tornado.
And that little detail, well, it's the key, because it leads us to a really mind-bending question. What if this famous effect isn't actually a cause in any way that really matters? And that, right there, is the philosophical puzzle we're going to unpack today.
Okay, so let's get right into this puzzle. At its core, you've got two statements about the butterfly effect that both seem totally true, but they also seem to completely contradict each other.
So here it is, the paradox in a nutshell. On the one hand, fact one, that tornado is completely dependent on that one single flap. If you could turn back time and just stop that one little motion, poof, that specific tornado would never happen. But on the other hand, fact two, the flap does absolutely nothing to change the overall odds of a tornado occurring. It doesn't make one any more likely or any less likely.
So how on earth can both of these things be true? I mean, it seems impossible, right? To get our heads around it, we need to split our thinking into two very different ways of looking at the world. The what-if world and the what-are-the-odds world.
So, what if versus the odds? Let's start by unpacking that what-if side of the puzzle. Now, philosophers have a fancy name for this, counterfactual dependence. But really, it's just about asking what if. What if you had a world that was exactly identical to ours, except for one tiny change? The butterfly doesn't flap its wings. What happens then? Well, the tornado doesn't happen. It shows that those two very specific events are linked. And this gets right to the science behind it all, something called sensitive dependence on initial conditions. Just look at this. You have two starting points for the entire weather system that are almost identical. The only difference is that tiny flap. But you let time run and their paths diverge wildly, leading to completely different futures.
Okay, so now let's flip over to the what-are-the-odds world. This is what we call probabilistic independence. And this point of view, it couldn't care less about one specific butterfly or one specific tornado. It's just asking, in general, does the type of event a butterfly flaps its wings make the type of event a tornado forms any more or less likely? And the answer is a flat-out no.
This is a great way to think about it. Imagine all possible starting conditions for the weather are like two giant batches of cookie dough. In one batch, the butterfly flaps. In the other, it doesn't. Now imagine the conditions that lead to a tornado are sprinkles. Here's the key. Both batches of dough have the exact same random proportion of sprinkles mixed in. So picking a cookie from one batch or the other doesn't change your odds of getting a sprinkle one bit.
So what this really means is that changing one tiny detail in a chaotic system doesn't steer the future toward a tornado. It's not aiming at anything. It's more like it just grabs the dice for the entire future of the weather and gives them a complete re-roll. It just reshuffles the whole deck, but it doesn't stack it in favor of any particular outcome.
And this all leads us right to the heart of the debate. Does the butterfly's flap actually cause the tornado or not?
This is where it gets really interesting, because when we ask our best philosophical theories of causation what they think, they give us completely opposite answers. The probabilistic theory says a cause has to raise the odds of its effect. Since the flap doesn't do that, this theory says, nope, not a cause. But then the counterfactual theory, which is all about that what-if thinking, says yes, it absolutely is a cause.
And look, this isn't just some dusty academic argument. What the butterfly effect does is it finds a deep crack in our very concept of causation. It takes two ideas we normally think of as being joined at the hip, making something more likely, and being a what-if difference maker, and it rips them apart.
So, where does that leave us? How do we solve this? Well, this leads us to a really profound idea. What if the problem isn't with the physics? What if the problem is with our word cause itself?
So there's this really influential view called the manipulationist theory, and it basically argues that the whole reason we even have a concept of cause is for a super practical reason, to help us manipulate and control our world. We want to find the levers we can pull that will reliably give us the results we want. But in that sense, the butterfly effect is totally useless. You can't start or stop tornadoes by managing butterflies. The connection is just way too delicate and unpredictable.
And this is exactly where the concept just starts to break down. As these philosophers point out, some systems are just unfriendly to our normal way of thinking about causes. The butterfly effect pushes the idea of cause into a weird new territory, where it's just not a useful tool for understanding or controlling anything anymore.
You know, there's a technical term for this kind of problem. It's called semantic indeterminacy. And really, all that means is that in this strange, chaotic situation, the word cause just becomes ambiguous. There's no single correct answer to the question because the word itself was never built to handle a case like this.
So in the end, the butterfly effect is so much more than just a cool science fact. It's actually a profound lesson in the limits of our own concepts. It forces us to ask a really deep question. When our everyday words start to fail us in the face of scientific reality, how should we even begin to describe the world? And that is a question worth thinking about.